Hi everyone. My name is Jian from Chinese Research Academy of Environmental Sciences. My research focus on the environment monitoring, air quality evaluation, source parchment for the PM2.5 and ozone, and also we did some work on the some cutting edge techniques in monitoring, for example, the sensors. Today, I will give you a presentation to introduce the rise of the next generation of air quality monitoring, including the how to verify, test, and its application. In the past years, China has established the largest air quality monitoring networks in the world. From the year of 2020 to 30, more than 1,000 sites have been established all over the country. And from the year of 2013, more than 6,000 sites has been built. All these sites were used to evaluate the air qualities in the urban area. In China, a lot of super sites have been built to help the governors and the policymakers to do the source parchment to make sure that they can get the full information of the sources of both for PM2.5 and ozone. Especially from the winter of 2016, there is a very big PM2.5 chemical component observation networks has been built in Beijing, Tianjin, and Hebei area. And this network were built for the source parchment in the regional side, especially in the heating season, means from the middle of November to the next end of May. For now, we have 3 levels of monitoring systems. In the bottom is the air quality monitoring stations. This means there are more than 7,000 sites to evaluate the air quality. In the middle of it is the PM chemical components and photochemical stations. We can monitor the chemical components of PM2.5 and VOCs and to make the source parchment. And on the top of this pyramid is the super sites. It's mainly used for the research. But now China has more than 80 super sites have been used. We have a lot of observation resources all over the country. But in the urban sites, people always want to know where the pollution happened. So we have some new approaches for the air monitoring. This is the sensor. In the past 10 years, sensors, air sensors have been well developed all over the world. For example, in Europe, there's a EU Net Air program. And they also draft a roadmap for the next generation for air monitoring in US. And also in Hong Kong, mainland China, a lot of sensors has been used for monitoring the air qualities in the street canyon. We have a primary survey in 2017. There are more than 3,000 sensors, air sensors that have been set up in Beijing. In North China, their number is more than 20,000. For the whole country, we estimate that there is more than 50,000. Most of this air sensors has been used to evaluate the qualities from the and emissions from the point sources, construction field, traffic sources, and urban sources. Also, some new applications have been developed in some cities. For example, in Jinan and Xi'an, people set the PM sensors on the taxis. For example, 100 taxis have been equipped with the PM sensor. When this taxis has drive all across the city, they can measure the PM2.5 and PM10 concentrations simultaneously. So it can give us a good air pollution map for the urban peoples. This map shows the dynamic variation of the PM2.5 distributions in Xi'an. So there one more layer of the air quality monitoring systems that has been added in the whole system. It's a so-called grid monitoring network. So this network were equipped with the sensors, and these sensors will be used for the source control and air quality management in street level. But for there is a very big problem in this system is the QA and QC. You know, in the first third level, we have researchers, we have the force part evaluation, a lot of standards and SOPs to make sure that the supersite, PM component size, and air quality monitoring stations has been take good care with these standards. But for the grade monitoring, for the sensors, there's no such good standards and no such SOP system to support the QA and QC. Normally, people use the lab evaluation, testing, and verifying, and also use field testing to make sure that their sensors are working. So we also try to use a different kind of sensors and use different sources. For example, the cigarettes, ambient air, and concrete dust to test the performance of these sensors. And we also organize some testing program to test the sensors performance in the field compared with the BAM and also TIOM systems. We found this had a good agreement with the PM concentration compared with the BAM method in most of the time, especially when the RH value is pretty low. This testing program has been conducted for 1 year, and after this testing, we have drafted the guidebook for PM 2.5 grid monitoring based on sensors for the Ministry of Environmental Protection. And this work happened in 2017, and now we are preparing to do more works to add the more species. For example, the NOx, SO2s, PM10s into the system, the guidebook. We also can introduce you some standards and guidebooks in other sectors. For example, the National Meteorological System and National Quality Control System. They also have drafted their own standards and guidebooks. For example, in the National Meteorological Testing System, they have published four standards, and in the railway station, railway system, the labor protection system, public health, metal melting, environmental protection, safety production, and mechanical manufacture systems. They also have drafted their own guidebooks for the measurement of the dust. And also, they have a lot of manufacturers. They also publish their own standards. There is a lot of standards, but we still have some big problems not solved. For example, most of these manufacturers always make the so-called 5 steps to make sure the QA and QC is good. They compare all the sensors when the sensors were produced and make sure that all these sensors can have the same result. And second step is set up the one sensor very near from the standard station, so compared with the standard method. And also when they set the sensors up in the field, and they can compare it with the station very near from this site. And also all this data will be uploaded in the cloud, and they have a conception, the so-called cloud calibration. But we can see the result. We have tried to set up 2 sets of sensors in the same area, A and B. After we use a similar method to calibrate all the sensors, but we have totally different results. This 2 charts shows the distribution of the PM 2.5 concentrations measured by this 2 sets of sensors, but it's totally different. This means that at least one of these sensors have a very big problem in their quality. And now, in some research programs, some researchers they believed in the result of the sensors, and they use these sensors to measure the concentration and put this concentration into the model to evaluate the model results. So if this sensors give a very bad data. So it means there is a garbage in and garbage out. So the QA and QC for the sensors is a very key point of the whole system. And we also try to develop some models to make sure we have a good data quality. And we compared the sensors in the fixed station and the sensors set it up on the Texas and compared with these two sets of data sets with standard methods. After some recycling on these 5 steps and use different models, we can have a very good correlation for this data size. So I think we can find some good ways to make sure that the data quality is acceptable. Future, we still have a lot of unsolved questions in urban air quality management. Sensors that can supply a good approach to help us to solve these problems. For example, in the future, when we use the sensors to evaluate the air quality in urban area, we not only can give you the data, but also can evaluate the temporal and spatial distributions in the street level. We don't need to use the street canyon models. We just can set up some more sensors and low-cost sensors. The second application scenario is when we make full use of these sensors, we can give a very clear and very reasonable decision-making supports for the governors. So these governors can make the decisions more quickly and more effectively. The third one, when we use the sensors, we can map all the air pollutions in the city, and we can know where is the polluted very near from us. So we can give some warnings for the health exposure risks to the city people. When we use the sensors, combine the sensors with the point of interest for the distribution of population, and also we can use these sensors, combine these sensors with the monitors, with the cameras, and also we can combine engagement of the sensors in other urban city management sectors. So it can have a lot of useful areas. It can be used as a part of the urban computing. We have a big environment problems, and we have a huge number of peoples and lots of cities, city operation systems. So when the sensors combined with the traffic, with the energy using, landscape planning, so we can make the city more smart. And make the decision making more smart. So this is a very brief summary for my presentation. And I think this is the best and the worst period for the air sensor, because we have a biggest market for air sensors in the world, but we don't have put enough resources for the development and testing and evaluation of the sensors. In the National Industry and Information Ministry, the development of sensors has been taken as one of the most important projects. And some of the sensors made in China has been well tested other countries, and they have proved that the sensors made in China is pretty good. And we also need to put more energies, to put more patience on the protection of our own sensor techniques. And also we need to know what is the major problems in the developing of air sensors. We have a lot of challenges, and we need all the manufacturers, developers, and researchers to work together to solve these problems. So we still have a lot of monitoring resources in China, and now we have the biggest monitoring networks in the world. And this network has showed a very powerful position in decision making. But the next step, we should rethink about the development of the use of the sensors, and we should develop more sensors with good data quality, develop the sensors who can calibrate by itself, and also we need to develop some methods to dig deeply for the data. There are hundreds of thousands of sensors that's been used in China. We have mountains of data, oceans of data there. We need a very good method to analyze this data, and we also need to develop more using scenarios. For example, we need to develop a method to monitor the emissions, to help the people to monitor their own health status, and also we can develop some very small sensor to combine with the smartphones, and there will be more application scenarios will be designed and to make our decision-making system more smart. Okay, this is my presentation here. Thank you very much.